Hi everyone, and welcome. Let's get right into it. You can easily make a train go in an infinite loop by disabling its destination station right as the signal in front of it turns yellow. This can be exploited to manually decide which path the train takes. Right as its train is arriving, I can rotate this inserter here to modify the destination of my trains. Next up, I want to show you this circuit, which allows two signals, one on the green and one on the red wire, to be transported along with the train as it moves from block to block. Here I can see that on these wires here, I have put arbitrary signals, a couple on the green one on the red one, and as the train moves through here, let's send it along, and the light turns yellow, these memory cells get populated with the contents of the previous block's memory cells as the train moves along, and as the train will go through each of these blocks, it will keep carrying that signal along. In a similar fashion, you can propagate these signals alongside the trains through splits and joins. So long as you have one memory cell per block, the principle works just about the same way as in the previous example. Here I've showed how this would work in a join here and how it would work in a split. And I put it on top of this split that we saw before that allows you to pick the direction. Now, hopefully you see where this is going. If I was able to have a signal come along with the train and be read by the intersection, could I have the intersection or my circuit network decide where to route the train to? What I've done is create a set of tiles that can be used to control your trains through the circuit network. For example, here's a join. The train would travel in this direction here. Here there's several things. There's the signal propagation alongside the train like we saw before. These are these three parts here. There's also a global circuit network on both a green and a red wire, as you've seen in most city block designs. And there's a third type of global network, and this one is directional. This is intended for pulses, and it travels in the opposite direction that the train travels in. As you can see here, there are identity combinators that work as diodes to allow the signal to only go in one direction here. This can be used for mapping your circuit network, mapping your train network into combinators, as we'll talk about in just a little bit. The tiles are all 32 by 32, as you can see here. This tile is a split tile with a train travel direction from left to right here. This circuit network can decide what to do with the train as it gets through here. There's a few things this incorporates. This incorporates the mapping, and in these memory cells here, holds the direction that the train should go to reach any part of your global train network. This also, of course, holds the signal propagation for the train itself and the global network. This allows the trains to be traveling in three different modes. According to which signal is being propagated along with the train can either operate manually. I still have this part here where I can decide which way the train goes manually. So if the train is set to be operated manually, it will go in the direction determined by this inserter rotation. The train could also be set to random, where as the train approaches the intersection, a random number generator that's running on the global circuit network will decide which way it goes. And the third mode that it could be running into is target destination, where it will have a signal that tells it specifically which station it wants to go to. For this, I've left room for 30 stations for each type of signal in the game, minus just a couple reserved signals. So for example, you could say, hey, go to blue circuit station number 17. And as the train approaches here, these memory combinators here will be compared to the target destination and tell the train which direction to go into accordingly. One more quick circuit to talk about is this one. This part here on the bottom is the same one we've seen before that allows the green and red wire to hold signals that are propagated alongside the train. This top one here allows the global network to modify the train as it comes through. So for example, I could have a unique identifier. I'm using unique identifiers on these trains, and I could send and say, hey, wherever this train is on the network, make it now change its status to now operate randomly, for example, or make it change its status to now be manual, or make it change its status to now be going to a specific station that I can specify on this global network. This means that as the train's moving, I can decide where to send it globally from the circuit network. These are actual stop stations for the trains. These are compatible with the 32 by 32 system as well. As a train comes through here, its data that's coming through its red and green wires will be compared to see if the destination, its intended destination station, matches this station. If it does match, then the train will turn in, so long as there's no other train already there. Let me show you a little bit what this thing can do. What I've created here is a tiling using these splits and join parts that I showed you earlier. And I've also already mapped a few locations here. These are the ones that are marked here using the tags. What this means is that because these are mapped for every tile, every split tile within this structure, these 3 memory cells here will hold the directions that a train coming into this intersection, into the split, would need to take to go to each of the stations that I've mapped. This is done through bit shifting. Basically, this can hold the locations for 30 stations for each signal in the game. Let's say I wanted to map one more location on this tiling. I would take this little mapping blueprint here and paste right onto basically any part of this network. And here on this station here, it defaults to this, but we would pick another signal. Let's say we wanted to pick, we'll pick the power armor. Now, all I have to do is drop any item here, do this, boom, this will go through the entire tiling and map each split intersection. In its memory cell, you should now see that power armor. So let's just pick any random split here, and within this, on one of these 3, I'll have the power armor. This means that if a train is coming through this intersection here, this split, it would have to go to the middle split here to reach the power armor location in the shortest route. As you can see, each one of these will now have this map, and there it is. Time to send some trains in. What this little rig does here is it assigns an ID using the locomotive signal to each train that I paste and sent through here. So what I'm going to do is I'm actually going to send 3 trains with ID 1. So let's just send these through. Let's make sure I'm set correctly here. It looks like I am. Let's send these through. So 1, 2, 3. So these all have ID 1 and they're set to random. So as you can see, these trains are sort of picking random direction through this tiling, and slowly they should start radiating out into this rail network. Now let's send a few more trains, and this time let's increment their ID. So here I'm going to send number 2. I set the rig up so that it will increment. So this will be now number 3. This will be ID 4. And this will be ID 5. Now all the IDs 1 are yellow, and the IDs 2 through 5 are going to be this cyan color. Okay, after fast forwarding a few moments to let the randomness take over, you can see that all the trains are spread out and wandering aimlessly through the network. Now let's call a specific train to a specific location. Here's my calling rig. I've set up this calling rig to call train 2. This tells the train that I'm giving it a specific target, so switching it out of randomness to now destination. And the target that I'm giving it is science 12. All I should have to do is turn on this combinator here, boom, like this. And now let's look at the map and see if anything is heading towards science 12, which is all the way up here. Okay, I got a train coming here. Is this the one? Maybe not. Is this the guy? Look at this one. It looks like this one. Nope. This guy came all the way from down here. And then here he goes around, and he should just keep circling around this location because he's reached his target. Let's just make sure that this is train number 12 here, and we go on this pool, and you can see that this train says on its green signal that's propagated along with it says that it is going to purple science 12, and you can see that its train ID here, the locomotive signal, is 2. So this is working great. Now, remember train ID 1, we sent 3 trains with train ID 1, those are the yellow trains. Let's try sending those 3 trains together to the power armor station, power armor location we mapped earlier. So I'm going to here switch this calling rig to call the power armor MK2. And all I'll have to do is turn on this combinator, and hopefully as we look through here, here's the station we're looking through, we should see trains starting to converge towards this location. And you see, there they are. Let's just make sure these are the yellow trains we sent earlier, and we can see these are the 3 yellow trains. As we look through the train network here on this signal, I can see here's the locomotive numbers. They're all ID 1, and with the power armor as their destination. So this is, again, working great. For kicks, let's bring these 3 trains together back to station blue circuit 3 here. For that, all we should have to do is change this signal to blue 3. There we go. Let's see if that's working. And where are the trains? Here they come. And now they're all circling around blue station 3. The last thing I'd like to talk about is some of the additional train metadata that I've built into the propagating signal. So here, I'm hovering on this power pole here because this holds the train information. As you can see here, we've already talked about the train ID, which is the locomotive signal. You can see the artillery targeting remote. That means that each of these trains is heading to a specific destination. And on the green signal, you can see that that's a blue circuit 3, meaning these are all circling around blue station 3. The other colored signals in here that we see, so gray, black, magenta, cyan, or blue and white, are a log of the blocks that the trains have been through. The black and gray signal are the total number of blocks the trains have been through. This can be used for automated refueling. So separately here, I've mapped a refueling location already through the black signal. Over here, all we have to do here is say, when do we want these trains to refuel? Right now, my refuel amount is 10,000. You can see the trains are only at 2.6K or so. So let's change this one back down to 2,700, 2.7K. And what that should do is send any trains that are above that number to go refuel. Now, it's doing this without changing what their signal is. So once these trains have refueled, all the refueling station would need to do is eliminate that black signal from here. And the trains, as you can see here, are still holding the same information they had before. So now that their black signal is back under 2.7K, the train should go right back to what it was up to, which is going back to station 3. So this is how the system parts and functionality stand as of now. The next step would be to create a concept base that would use this as its train network management system. I have some ideas on how to do this, but I would really like to open it up to the Factorio community, all you guys, and see if you have ideas of how maybe a central computer could be created to manage this network of train. Now that we can communicate, live with each train as it goes through, and maybe even remap stations on the fly, keep track of which station has what. There's many ways to do that, and I'd like to get everyone's idea about that. Of course, you wouldn't use this kind of tiling. You would probably make it look something more like this, where you would have room for stations between things in order to actually process your stuff. So yeah, let me know. Any ideas on like maybe improving this? I'm happy to hear anything about questions. As you probably imagine, there's been a ton of debugging about this, and I've worked hard to make this nice and resilient. But there still could be issues about it. So I'm looking for any interested people to open this up and let people, I'd like to collaborate with people and create something cool using this as its backbone. I'd like to thank Halki1986, who through the Technical Factorial subreddit about a year ago helped reduce the size or the number of combinators needed here to pick incoming pulses at random when dealing with a conflict in the mapping signals here. Halki, thanks for this. As you can see, this particular tile here has a lot of combinators, so anything that really helped to reduce the number of combinators needed for this part of the mapping rig. Thanks everyone for watching. Please comment below. I'll be happy to answer any questions. Looking forward to hearing what you guys think about this. So thanks a lot. Take care now.